Hello, I'd like to welcome you to EGR-225. This is Circuit Analysis 1 Lab. It is a co-requisite of, I believe it's EGR-221, Circuit Analysis 1. So you should be signed up for this lab if you're taking the other course. Basically, if you're following an electrical engineering path in the engineering transfer program, you want to take this lab with the associated course. This is an introductory, kind of really very dry material actually, course. We have never had it online before, but obviously because of COVID-19 here in the fall of 2020, we have had to do some different things that we haven't done in the past, and so we're going to attempt to teach this class online, totally online. You know, the preferred thing would be to have you go into the lab and to be able to take and make measurements with things like digital multimeters, use power supplies, oscilloscopes, and the like. But again, because of COVID-19, that's not going to happen this semester. What we are going to use is some simulation software. AutoCAD has come up with something called Tinkercad, and Tinkercad allows you to take and build electronic circuits. And the sophistication of the simulation program is such that it satisfies the needs we have for this particular course. You can build simple circuits with resistors and other components, and you can make measurements of things like voltage and current in that circuit. So we'll start the course by introducing you to Tinkercad. It's free, and it turns out that you can build these circuits online, you can share them with others, and you can make measurements. So the other thing is that Tinkercad has a graphical interface that is somewhat realistic. That is, you build circuits and they kind of look like what you would build in the lab if you had a proto board and the parts and components and so forth and mounted them on the proto board. What's not as realistic is the instrumentation, but it does the job, so that's neither here nor there. So some of the topics we'll take a look at will be things like series and parallel circuits, measuring resistance, Ohm's law. Then we'll look at some circuits where you'll make measurements and confirm the operation of the circuit through your knowledge of circuit theory, as well as verify things like theorems like Kirchhoff's voltage and current laws, Norton's and Thevenin's theorem, being able to solve circuits using mesh or nodal analysis, the principle of superposition. And we end the course with looking at circuits where the signals vary with time. Everything else is DC, so if I make a circuit, whatever I measure for voltage and current basically remains constant. And the last two experiments will take capacitors and inductors, and we will charge a capacitor and discharge a capacitor and energize a coil or inductor and de-energize it, and watch what happens with the voltages and currents through those devices as time progresses. They cannot charge up instantaneously, nor can they be energized instantaneously, so we end up with a time-varying exponential charging or discharging and a exponential energizing or de-energizing of magnetic fields in inductors. So that's where we'll end up. Next semester you'll have a course where we'll deal with AC signals, and they certainly are time varying. So without much further ado, let's get at it. Thank you.